Differentiating implicitly this function, we need to differentiate the log function first. That's my outside function. And as I differentiate the inside function, as I differentiate x, I just differentiate that normally. When I differentiate the y, I do it normally, but I also have to remember to tag on that chain rule. That's what generates the dy by dx. Do the other side independently, becomes secant squared of xy, and then again, I have to tag on as chain rule the derivative of the inside. The inside is a product, so then I apply product rule. So when I differentiate the y in the product rule, I generate a y prime here. Okay, so then I need to group together my y primes. Okay, so I'm going to end up with 2x squared plus y squared plus 2y over x squared plus y squared times y prime. So there's my y prime equals y secant squared xy plus x secant squared xy, and I have the y prime on that term. Okay, so grouping together these two terms on one side of the equation, I can choose either side. I think maybe we will put it on the right-hand side. And again, it doesn't really matter, but I'm going to have 2x over x squared plus y squared minus y times secant squared xy. Okay, there's no identities that let me simplify that, so I'm just going to leave it like that. And on the right-hand side, I end up with x secant squared xy times y prime, and I end up with negative 2y y prime, that's the y prime I'm going to factor out, over x squared plus y squared. Okay, so on the right-hand side here, I'm going to factor out my y prime. So I'm left with x secant squared xy minus 2y over x squared plus y squared. On the right-hand side, I have 2x x squared plus y squared minus y secant squared xy. Now when I divide this, I'm going to have kind of embedded fractions. I suppose I could simplify this, but really we can just leave it. So I'm just going to, first of all, just do that. So 2, although it looks kind of messy, it is pretty messy, and we may want to, it might not be worth simplifying this. Okay, so if you leave it like this, usually that's good enough. Okay, so this answer is probably good enough. However, there is this common denominator of x squared y squared. So I could simplify things, and it's not doesn't simplify things a lot. Okay, now this will cancel out some factors, so I end up with y prime is equal to 2x minus, this is going to be, I'm just going to leave it as a factor, x squared plus y squared, y secant squared xy. And in the denominator, we're going to keep that factored, so x squared plus y squared, x secant squared xy minus 2y. Okay, so this is not that much simpler than the original one, but we can kind of get rid of some of those embedded fractions if that might be useful to us.